Dear student, today we will discuss trigonometrical ratios of acute angle and standard angle. Okay, before going through this discussion, we will know about trigonometry. What is trigonometry? Now, trigonometry is the branch of mathematics in which the relation of sides and their ratios are measured, and the discussion between them is called is trigonometry. Okay, now we will discuss trigonometrical ratios trigonometrical ratios of an angle Okay, suppose a moving line, suppose OA is rotating towards anti-clockwise direction. Okay, and it goes, suppose, from this is OB. Okay, a moving line goes OA from its initial position to, suppose, OB, and this line, two line segment makes an angle theta. Okay, and a perpendicular is drawn on the line OA. Suppose this is P, and this angle definitely be acute angle. Why it is acute angle? Now, as the sum of the three angle of a triangle is being at 180. Okay, that's why it must be acute angle. Now we will know about trigonometrical ratios of with respect to this angle. Okay, with respect to this angle, this is the perpendicular, this is the base, and this is the hypotenuse. Okay, and we know and sin theta equal to perpendicular which is PM. Okay, and hypotenuse which is OP. Similarly, cos theta equal to base divided by this ratio. This side ratio represents the angle sin theta. Okay, cos theta equal to base by hypotenuse. What is base? Now here OM is the base and hypotenuse is being OP. Similarly, tan theta equal to perpendicular by base. Here perpendicular is PM and base is OM. And cosec theta is OP by PM, that is hypotenuse by perpendicular. Sec theta equal to OP by OM, that is hypotenuse by base, and quad theta equals to base by perpendicular. Okay, here base is being OM divided by perpendicular is PM. Here the trigonometric ratios are written down. Okay, now there is a point to be remembered to all of you, that the trigonometrical ratios of a given angle is always same. It does not depend on the size of the triangle. Okay, it could be proved very easily later on. You will be done. Okay, now relation among trigonometrical ratios. Now relation among trigonometrical ratios. Okay, as we know, sin theta equals to perpendicular by hypotenuse, and cosec theta equal to, we know, for a given angle also, here the angle is being theta, which is acute angle, which is being hypotenuse by perpendicular. This is an right angle triangle. If we look this, then we can write sin theta equals to perpendicular by hypotenuse, and it is being the hypotenuse, it is perpendicular. Okay. Let's see. If we multiply both of them, then we get sin theta into cosec theta equals to perpendicular by hypotenuse into hypotenuse by perpendicular. That is 1. This is a relation. That should be remembered. Okay. Sin theta into cosec theta equal to 1. Again, similarly, we can prove cos theta into sec theta equal to 1, and tan theta into cot theta equal to 1. Okay. Now some important results which are more important, that is to be remembered. Okay. Suppose this is a right angle triangle A, B, C. This is perpendicular, this is base, this is hypotenuse. Okay. Now we prove, this is the some important result, sin square theta plus cos square theta equals to 1. How can it could be proved? Let's see. Sin theta, as we know, sin theta equals to perpendicular by hypotenuse. Okay. Hypotenuse square. Okay. Cos theta equals to base by hypotenuse square. Okay. Now, if we take left hand side, then hypotenuse square LCM, perpendicular square plus base square. Now from Pythagorean theorem we can write p square plus b square equals to hypotenuse square. This is the Pythagorean theorem, and then we can write p square plus b square equal to a square by a square equals to 1. That's why sin square theta plus cos square theta equal to 1. Similarly, we can write cosec square theta equals to 1 plus cot square theta, and tan square theta equals to 1 plus cot square theta. Sorry, sec square theta equals to 1 plus tan square theta. It is not. Sec square theta equals to 1 plus tan square. This is the 3 important result that is to be remembered to all of you. Okay. Sin square theta plus cos square theta equals to 1, cosec square theta equals to 1 plus cot square theta, and sec square theta equals to 1 plus tan square theta. Okay. Now we will know the limits of the trigonometrical limit value of the trigonometrical ratio. Sin theta, as we know, sin theta is equal to perpendicular by hypotenuse, and similarly cos theta equals to base by hypotenuse. Okay, as we always know, P or B always less than 8. That's why sin theta and cos theta, the value of sin theta and cos theta should be less than 1. Similarly, not similarly, okay. Again for the values of cosec theta and sec theta, as we know, cosec theta equals to hypotenuse by perpendicular. That's why the value of cosec theta and sec theta should be greater than 1. Okay, this is to be remembered. And tan theta and cot theta may take any value. Okay. Now the value of a few standard angle that is to be remembered to all of you. Standard angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These are called standard angle. Okay, and the values of sine 0 equals to 0, sine 30 equals to half, sine 45 degree equals to 1 by root 2, sine 60 degree equals to root 3 by 2, sine 90 degree equal to 1. Okay, similarly for the other trigonometrical ratios like cos 0, cos 30, cos 45, there is a chart in your book. You should remember this from the book. Okay, thank you. Let do an exercise from your book. Suppose you have to prove sec square theta plus cosec square theta equal to sec square theta into cosec square theta. How can you prove it? Let's took the left hand side. Okay, sec square theta plus cosec square theta. Okay, we can write sec square theta equals to 1 by cos square theta. Okay, and cosec square theta equals to 1 by sin square theta. Okay, then doing LCM of cos square theta and sin square theta. This is the LCM. Sin square theta into cos square theta. Cos square eliminate, then we get sin square theta plus sin square sin eliminate, we get cos square theta, and we know sin square theta plus cos square theta 1, then 1 by sin square theta into cos square theta. 1 by sin square theta, that is cosec square theta, 1 by cos square theta, that is sec square theta. That's why this is the right hand side. That's why LHS, hence LHS equals to RHS proved. Okay.